Welcome to Algebra 1. The learning goal for this episode is to learn how to solve a system of linear equations by substitution. We previously learned how to solve a system of equations by graphing. That works, but if our solution is not a nice integer point, it can sometimes be difficult to determine the exact point from the graph. Therefore, we are going to learn another method called substitution. There are 4 steps to this method. First, solve one of the equations for one of its variables. Second, substitute the expression from step 1 into the second equation in place of the variable you solved for. Third, solve that second equation for the other variable. And fourth, substitute that value into the equation from step 2 to get your second variable. That sounds pretty confusing, but it does make sense once you see an example. So let's look at some examples. We want to solve this system of equations by substitution. In this case, step 1 is already done for us. The first equation is already solved for y. So we can now go to step 2. We substitute that expression, 2x plus 5, in for y in the second equation. So we write 2x plus 3 times, and then we substitute in 2x plus 5 for y. So 2x plus 3 times the quantity 2x plus 5 equals negative 17. Now we can simply solve that equation for x. We get x equals negative 4. Now we take that value of x, negative 4, and substitute it back into our first equation, y equals 2x plus 5. So we get y equals 2 times negative 4 plus 5, which simplifies down to y equals negative 3. So our solution is the ordered pair negative 4, negative 3. But we should check to make sure we didn't make any mistakes. So we substitute in negative 4 in for x and negative 3 in for y in our second equation. So we get 2 times negative 4 plus 3 times negative 3 equals negative 17, which works. Therefore, our solution is correct for both equations and is therefore a solution to the system of equations. Let's try another example. This time, neither equation is solved for a variable, so we have to decide which equation to work with. If possible, we always want to work with an equation where one of the variables has a coefficient of 1 or negative 1, because that will require less work on our part. In this case, the first equation has a 1x in it, so we'll pick that one and solve for x. So when we solve for x, we get x equals 3y plus 4. Now we're going to substitute that expression, 3y plus 4, in for x in our second equation. So instead of 3 times x, we write 3 times the quantity 3y plus 4, then plus 4y equals 38. We can then distribute the 3, simplify, and solve for y, and we get y equals 2. We now take that value, y equals 2, and substitute it back into the equation where we solved for x. So we get x equals 3 times 2 plus 4, which simplifies to x equals 10. So our solution is the point 10, 2. But, to be sure, we should check it in the other equation. When we substitute 10, 2 into our second equation, the 3x plus 4y equals 38, it does indeed work. So it is our solution to our system. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems. Just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So, for this problem, our first question is, what are we trying to do here? What we're trying to do is solve the system equation by substitution. Next question is, how do we do that? We need to solve one of the equations for one of the variables. Which equation should we pick? It's easiest to pick the first equation since it has a 1y in it, so we solve it for y. Now what? Now we substitute negative 4x plus 17 in for y in our second equation. So what do we do next? We simplify and solve for x, which gives us x equals 4. Now what? Now we take x equals 4 and substitute it into the equation we got for y. Y equals negative 4x plus 17. When we simplify that, we get y equals 1. Now what? We write our solution, 4, 1. Are we finished? No, we should check our solution by substituting 4, 1 into our second equation. It does check, so our solution works. Let's try another one. What are we trying to do here? Again, we're trying to solve this system by substitution. What do we do first? We decide which equation to solve for a variable. Which one should you pick? Probably the first one, since it has a 1x in it. What's the next step? We substitute negative 2y plus 51 in for x in our second equation. What's next? We simplify and solve for y, getting y equals 18. Now what? Now we substitute 18 in for y in our equation we solve for x. When we simplify, we get x equals 15. What's next? We write our solution. Now what? We should check to make sure it works in our second equation. It does, so we're finished. Let's try one more. Again, we're solving by substitution. What's our first step? Since one of our equations is already solved for y, we can substitute x plus 5 in for y in our second equation. Now what? Now we simplify, but we get 15 equal to 15. What does that mean? Since 15 is always equal to 15, it means that these equations are always equal. That means these lines are collinear, and this system has infinitely many solutions. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now, work out the problem, then press play to check. Here's the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem, and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve a system of linear equations by substitution. We did that by solving one of the equations for one of the variables, if it wasn't already done for us, and then substituting into the other equation. We then solved that second equation for the other variable. We then took that value, substituted back into the equation we solved for one variable, and evaluated it to get our second variable. We then checked our solution to make sure it worked in both equations.